Here's the bracket. We supply it with nuts and bolts. On the bracket, it's made out of etched brass and there's a half etched line. This is where you bend it. If we get the servo motor, the servo motor fits like this. The nuts and bolts through the holes. You can use it like this, but it's a lot better to run a fillet of solder down there, and it just makes it stiffer. This is one that we've soldered. My soldering iron wasn't powerful enough, so I did it on a gas ring. Servo motors come in many different sizes, but the most common for model railways is this size, which is described as a micro servo motor. With it come a pack of arms. This is the most useful arm for model railways. Fixes on here like this. This fixing's serrated. It allows you to fix it on at different angles. To make it really secure, they supply a very small screw which goes in the end here. On the bracket there are two holes for wood screws to fix it to the baseboard. These two holes, as we mentioned, use the nuts and bolts that we supply with the bracket. I usually find that it's best to link the mechanisms I want to move with the servo motor with a linkage made out of piano wire. Piano wire is a special steel that's very springy. It's also called spring steel. It's as hard as tool steel. On the arm of the servo motor are a series of holes into which you can fit the piano wire. It's quite easy to bend it with a pair of pliers. And put this into one of the holes and bend it over again so that it stays firm. Depending on the amount of movement you need, you can have a hole that's further along the arm. Now the thing with piano wire is, because it's made out of tool steel, it'll ruin your best cutters if you try to cut it with cutters. One way to cut it is to make a little nick with a needle file. If you hold the piano wire next to the nicks with a pair of pliers and then just twist it a few times, then it'll easily break off. We have a number of YouTube videos about controlling servo motors on our Heathcote Electronics YouTube channel.